Hi friends, today we will see the operation of single phase half wave rectifier. Single phase half wave rectifier. So before going to this, in this single phase half wave rectifier, I am going to use thyristor as my switch. Okay, so to use thyristor as a switch for any of converters, first we have to know it is a switch. So definitely there are two things. One is switch turn on and turn off things. Okay, so when a device will turn on and when a device will turn off, so these two things are very important. First we need to make a note of these 2 points. So for coming to thyristor, there are 2 points in thyristor. So one is turn on. So when a thyristor will be turned on. Okay, let me write turn on of thyristor. Yes, turn on of thyristor can be done by making the device forward biased and by providing the gate current. In the similar fashion, turn off of the device we should know when the device will turn off. So turn off of the thyristor will be done when reverse bias is applied and zero current will be applied. Zero current. So coming to this single phase half wave rectifier, here turn on can be done. So first we will draw the diagram and we will discuss how these two things are utilized in explaining the our single phase half wave rectifier. So I am drawing the circuit diagram. So this is the our thyristor. So here I am using only R load and I am giving the supply here. So this is the AC supply I am giving here. So let me call this as Vs as instantaneous voltage and Vm as maximum voltage. It will be Vm sine omega t and this value will be R resistance and this is V0. It should be in this direction and this is I0 and this should be in this direction. This is the thyristor T and the voltage across thyristor will be Vt. So this is the gate terminal G. Of course this is terminal anode and this is terminal cathode. So these are the things while drawing the circuit diagram. So these are the only, here if you can see, only three things are very much important. One is voltage source, second one is thyristor and third one is only load, resistive load. So here I am using only resistive load for our basic understanding. So if you can see here, so whenever positive off cycle is supplied, for example I am supplying the positive off cycle here, you can see in positive off cycle, see I am explaining this particular circuit diagram to draw the waveforms. Okay, once waveforms have been drawn, then we can come back and we can again analyze and finally we can come to a conclusion such that the things are true for both for both this with the circuit diagram and also with the waveform. So coming to circuit diagram, first this is the circuit diagram. So it is a sine wave. Sine wave is having two cycles. I mean in one cycle there are two waves, positive off cycle and second negative off cycle. So in positive off cycle, let me consider the directions like this, plus and minus, even though this is an AC. So we are discussing for the positive off cycle. So that's why I am considering this direction. Okay, plus and minus. As this is plus and these are the default things we have already taken, plus minus for Vt and plus minus for V0 and the current direction is I0 like this. Okay, so now whenever it is in positive off cycle, okay, positive off cycle, what will happen to thyristor? So if it is positive off cycle, the thyristor is anode is connected to plus positive terminal and cathode is connected to negative terminal. So what will happen? The thyristor is in forward bias. But unless you are providing the gate current, the thyristor won't turn on. So what will happen? So before giving the firing pulses or before giving the gate current, the thyristor is off only. Off means it is open circuited. Okay, so let me draw that waveform also. Let me draw that circuit diagram so that it will come to know clearly. So let me specify if gate current will be applied at firing angle alpha. Okay, firing angle means this is the angle at which we are providing the gate current, such that after which the thyristor will be turned on, and before that the thyristor is turned off only. Okay, so this is the case. So now I want to segregate one cycle into 0 to alpha. So what will happen from 0 to alpha? So it is my omega t. Omega t equal to 0 to alpha. What will happen to my circuit diagram? Let me see in which way the circuit diagram is changing. So it is very simple. This is my wave. This is my source. This is my thyristor. As thyristor is turned off, so it is open circuit in nature, and this is the conditions. Okay, this is Vs, this is Vt, and this is V0. So how can I understand this? So actually every time I need to go ahead with the voltage, Kirchhoff voltage law. Every time what will happen? Vs is equal to Vt plus V0. Okay, as there is no current flowing in this circuit because we are not providing any gate current to the thyristor will become off state only or blocking state only. So what will happen? There is no current flowing through this. As no current is flowing through this, I0 will be 0. As I0 is 0, what will happen to V0? V0 will be 0. Then what is Vt? Vt will be equal to Vs. So let me write these two things here. V0 equal to 0 and Vt is equal to Vs. Okay, very simple. It is from omega t equal to 0 to alpha in positive off cycle. Next, coming to negative off cycle, even positive off cycle is also not completed. So let us complete that part. If omega t is equal to alpha to pi, what will happen? If omega t equal to alpha to pi, what will happen? So here interesting thing will happen, because once omega t equal to alpha to pi, so alpha is the thing at which we are providing the gate current. So it is obviously turned on. So if it is turned on, the circuit will be like this. As thyristor is turned on, there is a short circuit at thyristor like this. As this is short circuited, so this is Vt and this is Vs and this is Vt and this is V0, and there is a current flowing through this I0. So as this is short circuited, V0 is equal to I0, current is flowing through V0. If you can see, these two are same, and I can also say that what is Vt? So Vt is equal to 0. So according to, if I substitute in this formula, if Vt equal to 0, Vs is equal to V0. So V0 is almost equal to Vs. V0 is almost equal to Vs. Of course, a small drop of Vt will be there, but that is very less, so we can neglect the same. So this is the case in positive off cycle. Now what will happen to negative cycle? So in negative cycle, it is again a very simple, same thing will come in negative off cycle also, but V0 will be, what will happen? Vs is negative now. Okay, now we can take it as, according to the direction only, we can take it as negative. So Vs will be negative now. So the same thing will happen, as thyristor won't conduct in the negative off cycle. We know that. Let me explain. At omega t equal to alpha, pi, at omega t equal to pi, at the edge of positive half cycle, at the starting of negative half cycle, thyristor will get 0 current and reverse bias. After that, after getting 0 current, the source voltage will be reversed. So once the source voltage is in reverse direction, we are getting reverse bias across the thyristor. So what will happen? So these two conditions satisfied, so my thyristor will be turned off at omega t equal to pi. This happens naturally, so this is called natural turn off. Natural turn off of the thyristor. Okay, so in this way, in negative half cycle, the thyristor will be turned off. So let me draw here, because I want to draw waveforms in this particular area. So let me go to this space. Yes, for example, if omega t is equal to, yeah, omega t is equal to pi to 2 pi, what will happen? Omega t equal to pi to 2 pi. Now the waveform will be, circuit diagram will be like this. It is Vs and it is open circuited, and this is resistance. Okay, this is V0 and there is no current flowing through this, and this part is also 0, so this is minus Vs. Okay, Vs, of course it is in reverse direction, and this is Vt. So there is no current, so V0 equal to 0 and Vt is equal to reverse Vs. Okay, so this is the case, and we can also extend our discussion to current also. So where is current? This is the resistive, this is the resistance. So it is simple, a resistive load, so we can have current always follows voltage. Okay, so I naught is equal to V naught divided by R, and here also I naught is equal to, everywhere V naught divided by R. So here V naught is 0, so I can say that this part is 0, and this is V naught is Vs, so Vs by R. Okay, so V naught is always following Vs. Okay, so it is the case actually. So here also there is no Vs, so I naught equal to 0. I naught equal to 0. Now we can easily draw the circuit diagram. You can see how simply we can draw the waveform now. Circuit diagram is over, so now we are going to draw the waveform. So gate current I have applied after some angle alpha, and in negative half cycle I no need to apply any gate current. So this is angle alpha. You can see this is angle alpha, and you can drop all these things like this. So drawing itself is very simple, but you have to be little careful. That's all, not more than that. So it's every time it's better to take two complete cycles so that you can explain completely. And it's very easy because every time we are following voltage, I mean source voltage Vs only. So once this part is over, now I can draw, this is omega t everywhere, and as you know this is pi, this is 2 pi, and this is 3 pi, and this is 4 pi. So first you should be clear like this, and this is alpha. Once this part is there, this is called 2 pi plus alpha. Okay, this clarity is very much required for everything. And now I want to draw output voltage, as output voltage is following output input voltage, I mean source voltage. So definitely I am drawing like this, dotted lines. You can see this. So as we, now it is very simple now. I am concentrating V naught. So from 0 to alpha, my V naught is 0. So up to alpha, my V naught is 0. So after alpha, I need to follow Vs, alpha to pi. From omega t equal to alpha to pi, I need to follow Vs. So my Vs is at this part. So I am simply following that Vs. Okay. Next one is from pi to 2 pi, what will happen to V naught? So V naught is 0. So again, V naught is 0 from pi to 2 pi. Later again same cycle starts. Okay, so from 2 pi to 2 pi plus alpha, Vs is 0 up to this part. Again it will continue like this. Okay, so I can draw with another color also. Let me show you clearly. See, this is the thing. Up to 0 to alpha, V naught equal to 0. Let me write this V naught. V naught equal to 0. From alpha to pi, V naught is following source voltage Vs. After pi to 2 pi, again it is 0. And from 2 pi to 2 pi plus alpha also it is 0. After 2 pi plus alpha, it is again following the voltage. After that it is 0. So this is the V naught explanation. Now let's move on to I naught. So how I naught will be? Let's move on to I naught. So this is I naught, and same thing, I naught is also following V naught. V naught itself is following Vs. So this is the way. So let me take some other color for the clarity. Yes. So same thing will happen for I naught also. You can see here I naught equal to 0 from 0 to alpha. After that it is also following the voltage Vs. Again it is 0 up to 2 pi plus alpha, it is 0. After that it is following this and then this. So kindly excuse me because I am unable to draw it properly in the graphic tablet. Okay, but it should be very neat. So now let's move on to the very important part, of course very easy part, voltage across the thyristor. Okay, voltage across thyristor is very easy if we know the Kirchhoff's voltage law. So it should also follow the voltage source voltage. So I am simply drawing this diagram. Yes, so this is voltage across thyristor. Now let me know what is the voltage across thyristor from 0 to alpha. From 0 to alpha, what will happen? Vt is equal to Vs. So up to alpha, let me draw. This is my alpha. So up to alpha, I need to follow Vs. So what is Vs up to alpha? So this is alpha. So my Vs source voltage is like this. So I need to follow this source voltage up to alpha. So after alpha, what will happen? After alpha to pi, Vt equal to 0. Okay. Up to pi, I am 0. Next, omega t pi to omega t equal to pi to 2 pi. What will happen to Vt? It is minus Vs. So this is minus Vs. So it is like this. That's all. Okay. Later again the same cycle continues up to 2 pi plus alpha. It is following Vs. After that it will be 0, and after that it will be minus. That's all. Very simple. Now you can see by your eyes, Vs is equal to V naught plus Vt. Okay. From 0 to alpha, Vt is equal to Vs and V naught is 0. From alpha to pi, what will happen? V naught is equal to Vs and Vt equal to 0. From pi to 2 pi, this V naught equal to 0 and Vt equal to Vs. In that way, it is following Vs is equal to V0 plus Vt. Okay, so in this way the operation is going on. It's very simple operation, so no need to worry. And coming to circuit turn off time, there is only one word, circuit turn off time. So this circuit turn off time is depending upon how much time we are making our thyristor to turn off. So in this circuit, the thyristor will be turned off from pi to 2 pi. So it is pi, 2 pi minus pi is pi divided by omega. This is called circuit turn off time. And I can also say that omega t is equal to pi. Omega t is equal to pi seconds. This thyristor was turned off. So what is the circuit turn off time? T will be equal to, which implies T will be equal to pi divided by omega seconds. Okay, this part also very important in our discussions. So if you have any more doubts, so you can put it in the comment window so that I can explain you better in which way you can understandable. So thank you so much for careful listening of single phase off wave rectifier. So you can also see in one cycle why off wave is coming, because in one cycle, every time in one cycle I am getting only one pulse. So that's why this is called single phase off wave rectifier. So here off wave is only rectified and second off will be zero, simply zero. That's why this is called single phase off wave rectifier. And as you already know that rectifier means it is conversion from AC to DC. So if you have any more doubts, you can contact me through comment window. Thank you so much. Kindly subscribe to my YouTube channel. Thank you so much.